Hi everyone, I'm Kathy Zip, Managing Editor of Solar Power World, and I'd like to welcome you to today's webinar, When Did Solar Monitoring Start to Matter? Hopefully we'll answer that question for you today. And before we begin, we'll go over just a few house cleaning items like always. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com, and it's also going to be emailed to all the registrants, so you will be able to view it again at your convenience. Secondly, there'll be a question and answer session at the end of the presentation. This is a great way to pick our presenters' brains, so we encourage you to participate. You can do so by submitting your questions at any time when they come to mind by just typing them into the GoToMeeting panel, which is on your right. Lastly, we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag SolarWebinar. And at this time, I'd like to introduce our fine panel of presenters. Today, we're thrilled to have Judah Mosen, Director of Operations and Maintenance Services at Infigen, Vasilis Papaeconomou, Managing Director at Electris, and Keith Davis, Director of Solar Services at Affinity Automation. So we'd like to thank extend our thanks to all our presenters for being here with us today. And Judah is actually going to be the first to present. He has more than 25 years of experience in the electric energy business, most of which has been spent in power generation in both traditional fossil fuels and, more recently, in the wind and solar industries. He has a Bachelor of Science degree in mechanical engineering and is a registered professional engineer in the state of Texas. Judah has directed efforts in engineering, construction, operations, and maintenance throughout his career. So we're very excited to have him here with us to share his expertise. And Judah, you go ahead whenever you're ready.
Well, thank you for that fine introduction. Hopefully everyone can hear me. And we're excited to say good morning, good afternoon, good evening, and good night to everybody, depending on what part of the world they're in that they've come to. We appreciate having everybody here. You know, solar monitoring on a 24/7 basis seems crazy when you look at it on the surface. But we're going to find out in our discussion today that it's not only not crazy, but it's absolutely essential and is now becoming a requirement throughout the industry. So let's talk about what's happened and what's going on. Okay, I think I skipped a couple slides there. Can you help me out? Okay, there we go. Perfect. So power generation as we know it is a 24/7 business. All of the steam electric stations throughout the world that are basically using some sort of fossil fuel, or in the case of a nuclear fuel, to boil water, to make steam, to turn a turbine, to turn a generator and make electricity. This is a 24/7 business. All wind farms operate 24/7, but I will talk about the fact that they have also been on a learning curve like the solar industry, in that they were not always bought into the 24/7 paradigm, but that now most everybody is, although there's still a few stragglers. The grid itself operates 24/7, and all of the utilities operate 24/7. Electricity is not something that can ever take a moment off, because when it does, everybody goes without. So therefore, if we take a closer look at solar farms, we'll find that solar farms are yet another power plant. If you're generating electricity and putting it on the grid, you're no different than a 1,000-megawatt nuclear or coal plant. In fact, what we're finding is that the regulatory people are putting some of the same requirements on wind and solar farms that they've been putting on the big nukes and coal-fired and gas-fired units. So, I mean, it is true that PV cells only operate in daylight hours. That is actually quite true. But the other essence is everything else is on 24/7. As we go down the list and we look at it, we have, starting from the panels and working your way out towards the grid, you have the DC collection system, the inverters, you have the medium voltage transformers coming from the inverters and running at usually 34.5 to the substation. In the substation, you have the medium voltage breakers and the high voltage breakers. You have protective relay systems. You have the main power transformers. All of this equipment is up and running 24/7. So the real issue you run into is what could happen to all of that balance of plant equipment during the nighttime hours that would keep the plant from operating at sunrise. Well, I can think of about 25 different things that could happen. And so without 24/7 monitoring, what happens is we, as a PV solar owner or operator, we deal with the surprises first thing in the morning. Now, others could argue that, well, the SCADA systems, they'll page or email people when they get alarms in, and if they're awake or if they have an alarm system that slaps them in the face when the alarm comes in at 2 in the morning so they'll wake up, maybe you could kind of try to stay on top of it. But we're going to find with 24/7 monitoring, and the requirement is somebody is always awake, somebody's always watching, ready to take whatever appropriate action there is to ensure that we're operating the way we need to be in the morning. So that brings the advent of 24/7 control centers. Control centers have been around since the beginning of the industry. They are a centralized point where you can monitor and control a single asset or an aggregation of assets, or in the case of an entire fleet for a company. In some cases like Infigen Energy, we operate and monitor not only our own fleet, but we have other clients that don't have their own control centers that come to us for that service. Here's some of the important factors that come out of having a control center. The first and most important one is the control center promotes safety. And what I mean by that is, at our control center and at most control centers around the country, when a technician approaches the equipment to work, the very first thing on his list is to call the control center and tell them that they're approaching. There's a couple of reasons for that. One is you want to make sure that when they start working out there and they inadvertently create a fault, that the control center won't actually try to restart the equipment if the fault occurs, especially when they know somebody's working on it. Now, hopefully the lockout and tagout procedure used by the technician will ensure his safety so that if somebody did accidentally try to start the equipment, they wouldn't be able to. But the call in makes the big picture that allows for the technician to notify somebody, like Big Brother watching. Somebody's watching, somebody remotely is watching 24/7, and so they know when they're there and they know when they leave. It also allows to have a historical record of who came and who went and when it happened. You'll find at control centers when an alarm comes in, the first thing they have to verify is it real or not? They have to start making phone calls, and if they call around and find out it's simply somebody that went in to do something and didn't tell anybody they were there, that doesn't promote safety. The other important thing is that we get issues identified in real time. So they're watching 24/7. So 1 o'clock in the morning, one of the inverter houses goes into a fault mode at a PV farm. Now, sometimes those inverters can be, depending on the fault, it could be remotely reset. And so if that's the case, then the control center can identify that the fault came in. It's on the list of faults that can be remotely reset. They'll attempt the remote reset. It gets reset. They make a note of it, and guess what? Nobody gets woken up in the middle of the night, and come morning, nobody knows the difference. Nobody knows that happened unless they look at the control center's activity log. Now, what if it can't be remotely reset? Then that's all of a sudden an opportunity to dispatch help. Now, most control centers will have protocols that will allow for the opportunity to know when it's time to call people out, okay? Depending on the severity of the situation, it may be that it can wait till sunrise or it can't. The most important thing is to do everything possible so that at sunrise, the PV plant starts producing electricity and putting it out on the grid. Now, what's even more important, and what people are finding out more and more as they make the move from residential commercial and they participate in these industrial-sized PV plants, that the grid considers you a power plant. And if you don't do what's expected of you, you get in trouble. And so the idea is, if sunrise is going to come and your plant's not going to be producing electricity, it's going to be producing less than what was projected, then you must communicate with them or suffer a penalty, usually severely financially. And what happens is you have to be able to communicate with the utility and the grid operators to tell them what happened, when you think it's going to be repaired, and how much you think you're going to be short come sunrise. Now, this is also important during the day. I've focused everything on the back hours, but during the day, the issue of 24/7 monitoring does promote safety, allows for real-time analysis and remote resets. All of these same things apply during the daylight hours, especially if there's a problem that requires a change in your projection to the grid. That same control center can work those things. But they're immeasurably more important during the nighttime hours to ensure that when you get to sunrise, you've got all the power you can. Now, here's what I've found, is as clients have been coming to us, we've been finding now more and more written in to PPA agreements, interconnection agreements, or even the scope of services that the owner is requiring, the words of monitor the solar array and the balance of plant 24 hours a day, 7 days a week, 365 days a year, is becoming a standard in the industry because people are becoming to understand that solar plants are power plants and they're going to be treated that way by the regulators, and that we all as an industry have to be prepared for that. And the good news is there's lots of people out there with control centers and with tools to make this happen. So that's really what I came to share today, and I will turn it back over to the moderator.
Great, Judith. Thank you so very much. Great insight. And our next presenter now is Vasilis. He brings executive solar photovoltaic development and construction expertise to his role as co-founder and managing director of a global operations and maintenance independent service provider. As a German-trained engineer, he drives continued improvement in every aspect of his company. Prior to Electris, Vasilis worked for a European solar EPC that he also co-founded. He's authored several white papers on operations and maintenance, and we are very excited to have him here with us today. So go ahead whenever you're ready.
Thank you very much, Casey. I'm really excited to be here with you today. And
you're a little bit hard to hear.
Point of view on why monitoring really does matter.
Vasilis, I think we're having a little bit of trouble hearing you.
Is it not better?
It's a little bit of interference.
Can you hear me better now?
Yeah, it is better now.
Yeah, I can hear you very well.
Yes, it's much better now. I'll let you know if you drop off again.
I got disconnected. Okay, I seem to have an issue with my internet. I got a bit disconnected. I hope, I can go well. Okay. So I was saying I was really excited to be participating in this webinar. Thank you very much for the opportunity. I'll try to explain in my presentation our point of why really monitor does matter. But I should take over control. Can you forward that slide, please. It seems that's not working for me. Katie, I'm still online.
We're still having a little bit of trouble hearing you.
Uh, I can hear you very well, but I don't seem to be able to take over control.
We appreciate everyone's patience. Let's see if we can find a way to resolve this. I think you should have controls now, Basilis. Are you able to move the slide back to where you need it to?
I can
You
hear
just have
you
to
very
move
well, Katie,
the
but
mouse
I
around. You
don't
should be able to
seem.
gain control.
Okay. Okay. Can you hear me
I think
well?
you got
Because it
it.
seems there's an issue with the internet. Can you hear me now? Okay. Okay.
Yeah, you're still
So
coming in and out
back
a
to the
little
first
bit
slide,
of
if you
interference.
may. Can you help me out there because it's a bit. Okay, will you help me out there and go to the first slide because it seems that I'm having a kind of trouble with that.
Yes. I think we have to go back one more here.
Okay.
Right there, right?
Okay. Okay. Right there. I'll need your help throughout that because it seems like it's not really working too good for me. No.
Sure, whenever you need the next slide, just say.
Okay, so I'll just start immediately there. We intend to present to you is, just basically three sections. Is just to describe what the current status of monitoring is globally, what the investor, what challenges the investors are facing, and how we perceive the fleet level monitoring is going to evolve to in the next few years. Can you advance that slide, please? So we've tried to gather some information from different sources in the market to draw the picture of the current situation in monitoring. So there are some facts that are undisputable currently. First of all, we see the PV solar market evolving quite rapidly. We see more gigawatts, more plants built globally, and not just in a few countries like in the previous years. Even the geographical distribution is getting bigger and bigger. So there are investors that are either constructing new plants in new countries, not just Europe or US anymore. It's Latin America, it's South Africa, it's Japan, it's everywhere. But we also see a pretty active secondary market, and that applies both to Europe and the US. That means that investors build fleets not just by new constructions, but by acquiring complete fleets by other smaller investors. One other trend that we also see in the market is, and that has been published quite recently in the GTM report about monitoring, is that last year the installations of monitoring systems have really outpaced the new installations of solar PV plants. So what that basically means is that there are investors that are actually changing the older monitoring systems of the plants that they are acquiring, or installing systems in plants that they do not even have a monitoring system. And as you know, that may sound quite extreme, but we have seen in the market plants that did not even have, even the basic monitoring system. Can we go to the next one, please? So, what are the challenges that the investors are facing currently? First of all, what we see at the plant level, there are quite a few plants that we have encountered in our markets that are underperforming. There are some of them that are completely distressed, but underperforming plants is actually quite a common issue. We've seen plants that they have very poorly planned and executed preventative and corrective maintenance. And in some regions of the world, security has become to be much more challenging than expected. Next one, please. Now, on the portfolio level, as regards to the O&M, to the technical activities, as I mentioned in the beginning, there are more gigawatts, more plants per investor. As you know, I showed in the first slides, these plants are much more geographically dispersed, so it's not just one single country or single location. There are older monitoring systems from the beginning of the solar era, which are completely outdated or ready to serve the needs of the investors. And there is definitely, in most of them, a lack of integrated approach of managing a global fleet. These monitoring systems, they're meant to manage simple tasks, but simple tasks per plant is easy to manage. If you go to a larger fleet and geographically distributed fleet, that adds a dramatic complexity to the management of these plants. Next one, please. Now, again on the portfolio level, what regards to asset management, there's what we have encountered in the market is that there's a clear lack of transparency of operations from mainly the O&M contractors. There is no proper reporting, no standardized financial or operational reporting. And one thing that is for sure, and we see actually across the globe, is that cash flows and margins are getting under continuous pressure. Next one. Now, on the policy level, and we have experienced, about that quite a lot from Europe. I don't know how many participants we have from Europe, but that would seem very familiar to them. There's been a tendency in many countries to abandon or change the feed-in tariff schemes. Such countries are Spain, Greece, Italy, quite recently, Romania, Bulgaria. There's been a fluctuating and unstable environment of the feed-in tariffs based on them, or it was the business model of all the investors. But also in other markets like US, the margins are getting lower and lower, and they're getting under huge cash flow pressure, so to speak. Next one, please. So what the investors are, have to do, given all the circumstances that I've described before, is they have to secure their margin in a very unstable landscape, in a very competitive landscape. Investors do have the need right now to have a better control on their assets and to optimize their operations and their management in a very cost-effective way. And by doing that, they have to, reduce their costs, try to keep the margins as high as possible, but also on the compliance level, there are a lot of tasks that need to be taken care of. And like I said, it's not just one country anymore. We're talking about multiple countries with multiple regulations. And although there are simple tasks to be done in every country, if you add everything up together, it can get actually quite complex. Next one, please. Just to tell you a simple example, because I've been saying throughout the presentation about complexity of managing operations. We sat with my colleagues, some weeks ago, and we counted the different tasks that we, as an O&M contractor, have to perform for a single plant, regardless of that size. We counted this task, and there are actually 96 different simple tasks, but still 96 tasks. Now, this may seem, quite easy if you're talking about one plant, but if you make a simple calculation, and I take this as an example, I'll say an average investor, not a small one, but not a huge one, that has a portfolio of 40 solar PV plants. If you make the calculation, we're talking about 3,840 different tasks. Again, individually, these tasks may be quite simple to accomplish, but the complexity doesn't come out of the individual tasks. It comes actually from the whole amount that needs to be taken care of. And again, if you take into consideration the geography, the geographical distribution with different regulations and rules across the countries, this efficient management quite a bigger challenge. Next one, please. So our perception is the following. When investors started investing in the solar PV market, a PV plant was considered to be a financial investment. Now, given the circumstances of the complexity of operations, I think nowadays a PV plant resembles actually much more an industrial investment and less a financial investment. Next one. So what is the real need of the investors as regards to monitoring? If there is anyone from the audience here coming from the industry, there is a very known term that we use there, and it's called the ERP. It's Enterprise Resource Planning. Such systems are, integrated solutions that help streamline operations, facilitate information flow between all the business functions of the industry, share data across various locations and fleets, and manage connections to all the outside stakeholders. So we're not talking anymore about a simple monitoring system that's measuring energy and radiance. We're talking about a monitoring system that's actually monitoring the operational cycle of all the fleets, of all the plants that the owner may own. Next one, please. So if I could conclude on that is, possibly we should redefine monitoring at this stage. So instead of just monitoring the outcome, meaning, the produced energy, I think the monitoring systems should evolve in something broader. And that's, in a complete solar ERP system, that's a term that actually has not ever been used for solar PV. And such systems should. So what should a solar ERP system of the plans of the fleet? And that is, there should be a complete service management module, ticketing, but not just simple ticketing, basically monitoring all the human activities that take place in these plants. There should be asset management there, so the financial parts of the plant, which is basically the outcome of the human activities, the financial outcome. But also, what should be there is an integrated management for the geographically distributed plants. And of course, since we're talking about an extensive set of data and not just two simple parameters that we measure in plants, there should be very extensive and customizable reporting capabilities. I think we strongly believe that this is the next step in the monitoring industry in solar PV. Until now, it has been only about measuring energy radiance, which was more or less what the investors cared about because everything depended on that. Now that the margins are getting really very low and cost efficiency is gaining importance, monitoring the operations and the human activities that lead to the financial result is going to be key to the cost efficiency and for the investors at the end. And I think that's the last one, if I remember well, Katie. Yes. Thank you very much. I'm really sorry for this, internet connection. We did some tests, it worked fine, but during presentation it didn't work. I do hope that I went through quite well and you had no trouble listening to me.
Nothing we can help with, Silas, and it all worked out. And we thank our audience again very much for their patience. So it's still a wonderful presentation. We really appreciate all that wonderful information. And now we have our final presenter, Keith. Keith Davis is a longtime electrical specialist and serves as Director of Solar Services for Affinity Automation. Keith holds an unlimited electrical contractor's license and has obtained the highest level of NABCEP Solar Installer certification. He is an entrepreneur at heart, having owned 4 different companies, and he brings that same strong drive to Affinity Automation. He's attended North Carolina State University. He's been involved in the electrical design and construction industry since 1974, and exclusively in the solar industry for the last 5 years. So we're very excited to have him with us. Before you begin, Keith, I think we're getting a little bit of interference. If we can just make sure that everyone except Keith's button is muted, and hopefully they'll take care of the problem.
Okay.
Sounds a little
Thank you
better.
All right.
Go ahead, Keith. Thanks.
Very, very good, Kathy. Thank you very much, and thank you all for being here. Let me apologize in advance for my voice. My doctor says I have some allergy and we can't figure it out, but I'm going to muddle through this. Probably will hurt you more than it hurts me. So I wanted to talk today about trends in the solar monitoring business. Jim and Phyllis both have given us excellent information. And so what they're telling us is there are going to be some changes made in the monitoring system. So we looked at our crystal ball and we see about 5 trends. I won't tell you the crystal ball is perfectly clear, but we do our best. And the first one is really the trend that drives their other 4, and it is that the standards that this industry expects are going to change. There we go. They're going to allow the inverter to do much, much more than it does today. So today, our inverters in a lot of ways are just a big dumb box that convert DC to AC. But there's going to need to be more functionality. The utility will demand it from that. It also is going to want to be more ability to regulate and to control and set things to parameters that the utility desires. Going along with what Judith says, if this is a power plant, it has to be controllable much as a power plant. And so that's the third piece. New controls will be in place into the inverter and into the system itself, even much deeper than that at some point. And we'll look at that in another slide. So when we get this, when the UL and IEEE and the NEC and the NFPA and all the alphabet soup of the regulatory agencies hopefully come together in the near future, we'll have a permanent standard that says your inverter can do this, your sub-metering can do this, but in the meantime, IEEE and UL are working on 1547A that will allow a much more inverter function and more control in the interim, even if that inverter is your inverter and not necessarily the utilities. Trend number 2, with that, solar monitoring becomes, as much as Vasila said, is not just looking at the revenue anymore or just the energy stream out of it. However, it is now a bidirectional stream. It is a two-way glimpse into the system and two-way control of the system, as well as letting it have data go back and forth from the operations center that Judith had talked about this morning. So not only the inverters are going to be that, but I submit to you that anything with a microprocessor in it, which could be a combiner, could be any of your protection systems. Thinking about the ground fault detection, the arc fault detection, your rapid shutdown systems, these will all have a microprocessor in them, and they will be able to be monitored and controlled, as well as the utility interconnection itself. Right now, the utility looks at that, but there's going to come a time where you will want to see that. What's my power factor? What's the amount of bars I'm injecting or taking from the grid? Where is my voltage levels? Where is my current? And so we will, in the industry, start having a deeper and deeper insight into that. And so that it's not monitoring anymore, it's truly SCADA. For software control and data acquisition, in our office, we call it solar control and data acquisition. And so that's going to be required by the utilities. And they're going to expect different protocols. Modbus will be around, TCP will be around, DNP3 will be what they're used to doing. So be prepared for that in your business. So tree number 2 is so big that it's going to become a permissible and expected to allow the inverter control. We can't do that today. If a blip occurs, the inverter trips, it goes offline, all of a sudden we've lost how many megawatts of energy, which is very disruptive to the grid, very hard on the inverters too, to have them shut down because of a blip in the power or just a momentary loss of frequency control. And so we're going to have the ability to do more in that thing. So this control will provide these different things, a voltage and frequency ride term, much longer than the 3 cycles or 30 cycles that we see today. It could be into seconds of control time, as well as regulating the voltage so that we're not plus or minus more than a very fractional percentage. Duke Energy's done some work here, and they're keeping it down to less than 0.5% with some test work they're doing on a site. They're also going to be able to curtail the inverter output, which is not at all what we're paid to do. We're paid to generate as many kilowatt hours as we can. So the curtailment is good for the grid if they don't need all that energy, but then there'll have to be a new financial model set up to say, how do we get paid when we're not delivering kWhs? But is there some way of measuring the DC that comes in? Again, that's a new task for somebody in the metering world. The power control will be a part of it. The power factor and VAR support. Again, if this is a utility plant, the utility is going to say, I want to control it, just like it's that nuke or that steam plant up the street. So look for that more and more control will be doing that. You missed that last piece, but California is leading the way, and they're taking the lead on that right now. Any of you who were InterSolar and attended any of the conferences on smart inverters, heard from CalCia, from some of the big EPC firms, what they're doing. Again, here in North Carolina, Duke is starting to do that on an experimental basis. And I think it's just a matter of time before it becomes the norm and the standard. So we touched on this in part number 2. Anything with a microprocessor will be connected to that monitoring system. We've done some work with Bender and their ground fault detections. They have a data stream that flows out of that can be parsed and looked for trends in ground faults. So our fault detections have a Modbus connection too that tells much about what the signature is. So these site communications requirements are now going to take a quantum leap forward. You're going to need to have a much more robust network than what you're used to having today. A cell modem may or may not be enough. We've done a couple sites for cameras, and the cell modem gets bogged down real quick. So we brought in a T1 line for some of those. So be looking at that you're going to need to be as much an expert in networking and creating that so that the utility can have access, you can have access, the owner and the operator can access. Again, Ethernet is now the protocol of choice. We do a lot of Modbus still, but a lot of people are very familiar with Ethernet and due to the web. A good old Modbus is still in the mix, as I said, and then again, DNP3 will be what the utilities expect. That is their protocol of choice today. So you're going to have some education ahead of you as well. Sprinkle water. So it's all about the data stream and the commands, the data going out and commands going in. Okay, now this is what I call the big data slide. We've all heard about Amazon and Google and big data. I submit to you that your monitoring on your website, I mean your solar site is going to become big data as well. Currently today, we typically look at 15-minute snapshots. Some systems take a 1-minute snapshot and average it. Others can now take it in 5-second snapshots and average. So depending on what you want to see in the granularity, you're going to start to see a lot of data flow out of these systems. And again, not just energy production, but operational parameters of the inverter. What's my temperature? What's my fan speed? What's my heat sink temperature? What are my power factors? What's my bars? What am I injecting? What am I rejecting? There's so many points that could be just in the inverter. Add the string level monitoring or the zone level monitoring for voltage in DC, and then start comparing. What if I've got a DC feeder that's running 12% less than the other feeders? Have I got something wrong? Maybe it's time to dispatch somebody. Again, that remote operations center that Judah's talking about can help dig through all of that data so that you're not up watching it in and out. Software tools will be the pieces that have to do that. It will not be a guy sitting there watching data flow and expecting to be able to pick up those things out of that. So we're going to start looking for data mining, SAS, SAP, others like that, being called upon to look for trends, to find that needle in the haystack, that one blip of where I've got a potential arc fault, or my ground, my differential current in my DC feeder hit 122 milliamps for 36 seconds. Why did it do that, and where? So it's going to need more analytics, determining what the system's doing, how it is doing, comparing to what its standards are. What are its expectations? I need to analyze it and watch it. Again, here's where your operations center can help you with that, particularly overnight when a lot of your reports can be run when there's not that big, huge stream of data. And then reporting. I need to see what my system's doing. I need to see it every day, particularly if there's a problem, if there's been an issue overnight or a challenge of some kind. Solar in 2014 and beyond is no longer a build it and forget it system. The first systems were. The first one I built 5 years ago didn't even have monitoring on it. Obviously, it's been retrofitted today. And we need to have that insight into that because it can help you as an owner, an operator, particularly if you're out there doing the maintenance, particularly if you've got to go out and find that you've got a ground fault somewhere in the system. What if the system said it's really in data circuit 16, which is tied to combiners 8, 9, and 10, and then you can narrow it down. So we want to see that the big data helps us. It doesn't overwhelm us with the flow of data, but we have the tools in place that it becomes very, very helpful to allow us to build and operate and control these systems better than they could be today. Trend number 5. And our local utility here, Duke Energy, has already started floating this idea around that the utility will now be the owner of the inverter, not you. Now, I think that will meet with some mixed skepticism and some positive ideas across the industry. But I can see their point. If they want to control it, they really need to own it. And they are going to want to control it because there's more and more megawatts come online. It makes a big difference in what it can do. It's not like we're putting 5 kW on a residential roof. You know, you're building 20, 30, 40, 50 megawatts at a time. And a SCADA system is going to be absolutely required. They will expect it, demand it, and you will have to provide it for them at a cost, obviously. And that way it allows them to set the parameters that affects their distribution circuit, or in some cases their transmission circuit, which is to the utility engineer, is the most important thing in the world, is to keep that frequency at 60 hertz, the voltage where it's supposed to be, the power factor where it's supposed to be, because that is their livelihood. That's their stability. They want to do that. So no longer will it just be how much energy we deliver to the grid, but how much can we work with the utility. And again, how can we make that a financial piece? How do we get reimbursed for being able to adjust power factor and bar support? Again, some new models will have to come out. So those are the 5 trends. Real quick, standards are going to change. And they're going to create some new opportunities for you. Come on, slide change here. There we go. Remote systems going to become the norm. The more hardware is going to be connected, big data is going to be out there, and you'll need to work with it, and utilities will become the inverter owners. So what are our conclusions about this? First, it's a brave new world in the solar monitoring industry, and I am happy to be a part of it. I embrace this. I hope you will too. Be prepared to take advantage of the new opportunities that will come and will come very, very soon, I'm sure. Now, you can sit back and do nothing, but that's really not a viable option. So learn all you can about these trends to support your customers, enhance your business, and increase your profitability. And with that, I say thank you very much for your time and attention today. Kathy, it's all yours.
Wonderful, Keith. That was excellent. Really appreciate it. And now, after all the information from our presenters, we do have some questions, so we'll begin asking those. You can still submit questions at any time during the question and answer session here on the GoToMeeting panel that's on your right. So we'll start off here. I feel like most of these first questions will apply to anyone, I think, any of our presenters. So I'll just ask, and then whoever wants to chime in can, and then if someone else wants to answer or comment, we can do that too. So someone's wondering, how many data points do you suggest should be captured for a 1 megawatt AC PV array? So whoever wants to jump in on that.
This is Judah. It's easier to say what data is available, like Keith was saying. If you actually incorporate every microprocessor in the system into your SCADA system, you will be amazed at how many data points it is. It will be hundreds, if not thousands, of points. It can be overwhelming, but you need to focus on what points do you need to know and what do you need to know to send out a control signal to make a change. So I'd say the easiest answer is take all the data you can, because you're going to need it.
And I echo that point and agree 100%. More data, the better. I think in the past we've had issues and problems where we didn't have a transparent data flow. And so I would really say take it all, but set priorities to it. Energy delivery is obviously a very critical one, but there are other operating parameters as well, like transformer temperatures. We actually have alarms set up and alerts for transformer temperatures, inverter temperatures, reduction or a change in current flow in one conductor versus another. Because there's signals of trouble. And if I can be proactive, then I can actually head off that trouble before it becomes a real disaster, or an inverter melts down and I've lost, for the sake of argument, a megawatt of delivery for 3 weeks. So get it all, but learn what the key points are and learn to filter those out.
Yeah, I honestly couldn't agree more with both Judah and Keith, and specifically underlying what Judah said, that you have to get what you have. Our experience has showed that there are some older plants that have very limited capabilities of grabbing data, and the bigger question there is how much would that cost to upgrade that and get more data in the system. So I don't think from the IT perspective it's any problem with the technologies that right now exist to process and transfer and process massive data. I think this problem has been already solved in the IT industry. And really the easy answer, and I completely agree with both Judah and Keith there, is just grab everything that you can, and then you decide later how to, how to use this data with the analytics and reporting on the server level.
Thank you all very much. Here's another question I think is interesting. Are there any security issues that are being seen in the monitoring industry?
You know, you were breaking up.
Or do you
Kathy,
have
when
to
you
take
read
any
that.
precautions against this?
I was going to say, repeat that again, Kathy.
I'm sorry?
I lost some of that. Repeat
Oh,
that
okay.
question again.
Okay. Yeah, are there any security issues that are being seen by the industry, and is there anything people need to do to protect their systems against this?
Oh, indeed. Again, once we're out on the TCP world, IP, we're out on the web, and I don't know why a hacker wouldn't say, you know what, let's shut this system down. So I think a very robust firewall and very robust security procedures and very robust access control into the system are critical. That we don't allow a hacker into the system, that somebody who's messing around, upset something, sets a power factor that actually causes the inverter to fail. So yes, definitely, when you're on that network, make sure you've got a good network team behind you who understands internet security, firewalls, and access control.
Yeah, and I'd like to jump in 1 second and just add to what Keith said, that this whole idea of 24/7 monitoring control is new to the PV industry, but it's not new to the power industry. And there have been NERC protocols in place for data security, and all of the major utilities and many of the wind farms are fully compliant. Of course, our control center is fully compliant. So, as Vasilis said, the IT technology is there to protect the data, but you have to make sure to deploy the correct solution so that you have your bases covered. It's helpful to get an expert to do a review of your system to ensure it's secure.
Mm-hmm. Well, to be honest, I've never heard of any incidents like that, but that's not really a big surprise because PV has not been a target for hackers. I mean, it's not in it can be a target, but as the industry grows, we cannot really exclude that. And I think investors and companies that are having and dealing with monitoring systems, they have to deal with that early enough. Because once you have an established system and large fleets that you're monitoring, changing IT infrastructure and applying security protocols there is going to be quite costly and quite complex. I think, although the industry, I don't believe it's a target today, but it could very, very well be in a few years from now, and we have to take care about the security already now.
Good insight on that. Thank you very much. Another question here. How does machine-to-machine communications and mobile workforce management kind of fit into monitoring?
I think that's a great question. M2M has been a topic in the industrial world for a number of years now. And I think it will come to the point in the utility scale solar business where you'll have nodes around the site, and maybe it's through Zigbee or Z-Wave or it is on the internet, that these pieces will talk to each other through a mesh network and aggregate the data. We're not there today, but that's not to say that it couldn't be the case. We've done some industrial control work, non-solar, that has that capability with the little nodes around the factory floor. And I don't see that being too far off, particularly if you can go to a string inverter and all of a sudden they can communicate wirelessly rather than us having to run a Modbus circuit to 32 inverters and then connect to a gateway. Think of the cost savings and time savings if you could just set it up as a little Zigbee mesh network, and then they're able to communicate back to a master controller. Some of the DC to DC optimizers have set that up already, and it very well may come in the string inverter piece as well. So building in the intelligence to the machines allows that communications as well as the acquisition and aggregation of the big data. So again, that goes in with that third trend that I talked about earlier.
This Judah, another piece is related to just general workflow. So so there are many products like Maximo and others that are workflow products out there that as an issue comes in and technicians are dispatched, they can be dispatched with real-time information about what's going on in the situation, what tools they need, what spare parts they need, and that workflow can be tracked, and it can work its way to a handheld device the technician is carrying with them on the job. And that's just a side benefit of the technologies that are being deployed around industrial complexes.
Okay, I think we have time for a couple more here. Can you talk about string level monitoring? Do you think it's worth the investment?
Well, I've heard that question debated both sides of the coin. The first one being that the string level monitoring is too much, it doesn't matter. I just want to monitor at my DC feeder coming into the inverter. That gets it down to a combiner box. And that's true. The string level monitoring, again, can give you much more insight into finding that string that has a mismatch in the MC4, for example. All the rest of them are running at 6.2 amps, and this is running at 5.8, and it's consistently getting less. Well, that tells you something's wrong in that string, and you would never find it without that until the MC connector absolutely fails because it's got an arc in it. I'm a big proponent in it. We actually have a small system on our roof. We do monitor the strings. It's interesting to watch the interplay between them as sun angles are different on each part of the roof. On a big scale system, it would be a lot of data. And again, that goes with the big data I talked about. Again, a control center or some kind of data mining hardware would allow you to look and spot the trends, which is what you're really after. You don't really care about the absolute value so much because you're not going to do the calculations on 686 strings to determine if your PV system is running at maximum efficiency. I want to know that the strings in each combiner box are fairly equal, allowing for soil and mismatch and that kind of stuff. So I'm looking for trends. And I would say, yes, do string level monitoring.
Yeah, I agree with what Keith is saying. There's been an evolution, and we're talking about an evolution of no monitoring, daylight only monitoring, 24/7 monitoring. It started that your data only went as far as the inverter. Then the data went down to the combiner boxes. Now it's going out to